and a speaker in some events. So the course overview, so we are in day 4, and today's is going to be around networking. So we're going to talk about virtual networking, name resolution, so DNS, about security and how can we secure virtual networks, and also about load balancers, so the Azure load balancers and application gateways, and also how to monitor and troubleshooting networks and how can I integrate my networks with Azure virtual networks. We're going to talk about VPN connections, peering, and we're also going to talk about express route and when to use ones or the others. Until now, so we already covered Azure identity and governance. We already talked about Azure AD governance, policies, subscriptions, RBAC. On day 2, we cover everything about storage. So we talk about storage accounts and Azure files. On day 3, we talk about compute resources. So essentially about virtual machine scale sets, containers, Azure Batch, web apps. So all of those were topics that we covered. And then still on day 5, we're going to talk about Azure Monitor and how can we implement a backup and recovery strategy. But let's just focus today and let's focus on how can we manage virtual networks. So we have a very busy agenda today. We're going to start with creating connectivity between virtual networks. What is a virtual network? Implementing and manage them, configuring name resolution, so DNS. We're going to talk about NSGs. We're going to talk about Azure load balancers and all the types that we have and when to use ones and the others, best practices, all that stuff. And we're also going to cover monitoring and troubleshooting virtual networks, and then how can we integrate our own network from on-premises with Azure virtual networks. So, but let's start by the beginning. Let's start talking about Azure Virtual Networks. So Azure Virtual Networks is a service that has a specific set of tools and resources for building cloud-based network architecture for our organization. So Azure Virtual Networks, they provide a secure virtual communication channel that all the Azure resources within our subscription and a region can then use. So examples will be connect virtual machines to the internet. You need to place them inside a virtual network so they have the channel, to go to the internet. Also provide secure communication between Azure resources that can be hosted in just one single region, but also when they are hosted in different regions and we want to communicate and put them all together and working all together. And of course, isolate and manage Azure resources because sometimes we really don't want certain resources to have access to the internet, for example. So we have a security policy that forbids that. So we want to really have something really private. And then I want to connect my on-prem machines onto that virtual network, always through a private channel. So we need a virtual network for that. So a virtual network is composed by several elements, like virtual network interfaces, so usually NICs, load balancers, subnets, network security groups, public IP addresses, but we even have way more other resources. And if we talk about key networking services, well, you can see that I have literally a lot of different network services that make what we call Azure networking. It's not just creating virtual networks, it's also Azure DNS. It's also content delivery networks, traffic manager, express route. It is also load balancers, VPN gateways, application gateways, Azure firewalls, DDoS protection, virtual ones, Azure Front Door, Azure Bastion, and also the new shining service that is the private link. So all of these services that you see here, they make use of what we call the Azure network backbone, and we can put them in the same, let's just say your container, that it is all around networking services. So it's not just, oh yeah, I have a VNet and then I've just put virtual machines inside. It is much more than just that. Like for example, the network interfaces. So the network interface basically will enable a virtual machine, so an Azure VM, to communicate with some network devices. And when I create this network cards, like imagine like in a physical server, when we have really a network card, well, we need to have a network card so that we can connect that machine to a network. And then, of course, from there on, I can then access the internet. I can access a network, some other resources that are on the network. Other resources can then communicate with me. All of this, of course, I can then have devices on the network, like a DNS server that will basically do the DNS work. And I have to, on that NIC, to specify, okay, what are the DNS services that I'm going to use. And so here is no different, okay? So everything is virtual. I don't have any physical servers to manage here. Everything is virtual, but it is kind of the same thing. So your network knowledge, it will be, you just need to adapt a little bit that knowledge and how to understand how does DNS works in here. But look, Microsoft didn't reinvent the wheel with DNS. They didn't reinvent the wheel with IP addressing. So they are just using the existing standards. It didn't make any sense to just create something else, okay? Even when we have protocols that we know they're old and they could be improved, and again, why should Microsoft do that on Azure? It will just generate confusion and a non-standard uses, and that's not the idea, okay? The idea is to use standard stuff so that then I can attach here any OS that I need, because, well, the OS will follow the standards, so we should be good. Also, I can also associate or dissociate network security groups. I can delete network interfaces. So all of this is our actions that I can do in my network interfaces. So what about on-premises IP addresses? So this diagram here that you see here shows a simplified version of what is a typically on-premises network. We have routers facing the internet service provider. I have a public IP address that is used by our outbound internet traffic as their source. I have addresses also that are used for inbound traffic across the internet. My internet service provider might assign me a block of them, so that then I can assign to my devices. So, and then basically I have then some perimeter network there with a web server, a mail, and a DNS server. And then I have a firewall workstations. So typically what we're talking about is that, well, typically on-prem network, I have devices like routers, firewalls, switches that compose them. And I have what we call network segmentation, so that I can have some services in a segment of my network and others in another one. This is not so different than what we have when it comes to Azure. So in Azure, you see this network design that you see in here. They have functions and features that are just similar to what we saw before. So the Azure network does not follow the typically on-premise hierarchy network design. So that's the difference that we have here. The network in Azure provides the ability for you to scale up, scale down the infrastructure based on demand. So it's not like physical devices that you're stuck with them. Even if you need more capacity, well, changing the devices takes a while. In here, because everything is basically virtually, it's a software-defined network. So you can just tweak it quickly and get more capacity in some of the services, like, for example, load balancers, for example. It is a good example of that. Virtual machines, the same thing, but like NSGs. So all of this, we can just scale them up. And then here, what you have here in terms of services, it will be what? It will be, I have virtual networks, as you can see there. I have basically, that's one virtual network, what you see over there. Then I have two subnets, a front end and a back end subnet. I have some NSGs that provides some control on the traffic that goes inside each one of the subnet, because in the picture you can see that they are associated not with the NICs but with the subnet. I can also have firewalls to do a better and a more advanced control of the traffic. And I have there some load balancers. You see, I have the first one on the top. that goes straight from the internet goes there. It's a public-facing load balancer, so it will have an IP address that is a public IP address. And then it will distribute traffic between all those three virtual machines that compose our web server farm. And then if those machines still need to communicate with the database tier, you see that's where we have in the backend subnet. So we can, and all of those VMs will have a single point to communicate, which will be the host name or the IP address, okay, of that internal load balancer. This way, that load balancer can only be reached from within the virtual network. So if you're outside this virtual network, if you're in the internet here, you can't access directly that load balancer. So talking about IP addressing, so we have a difference between public IP addresses and private IP addresses. So public IP addresses, they are used to communicate with the internet, including an Azure public-facing service like VM NIC, for example, internet-facing load balancer like we saw in the previous diagram, or a VPN gateway, or an application gateway. There are some best practices that says that it's not very recommended to have virtual machine network interfaces with public IP addresses. So watch out for that. Only use it if you really have the need for something like that. You might not need that. So again, be careful with that. Also, private IP addresses. So they are used to communicate just within the Azure virtual network. And if you have that VNet also some way integrated with on-prem, I can also communicate it through on-prem, through a VPN gateway or express route circuit. So that basically it's where I extend the network to Azure, but we're going to touch on that in the end of today's session. So private IP addresses for a VM. So as you can see here, I have a virtual machine. I have an automatically assigned private IP address from the range of the subnet that I chose to deploy my virtual machine. This address is then retained by the VM until I delete the VM or I deallocate the VM. Okay, so if we do a dynamic private IP address, so if you deallocate the virtual machine, that IP gets free and can be assigned to another VM. If you do this, okay, if you want that not to happen, yeah, you can just create a static IP address for that NIC, and then in that case, even when you deallocate that IP address, it will not be freed up. So it will be attached still to your VM. So virtual machines with a static IP address, so a public IP address enables you to communicate to a virtual machine from the internet, like we already saw this. And again, it's kind of the same thing. Usually this is dynamic. So again, if I stop my machine, that IP address will change. Well, even worse for a public IP address, probably you don't want this because you already have DNS records with an A record that points to that IP address and things like that. So basically you just might not want that. So you can go for a static IP address. So you just choose a static IP address and boom, there you go. You're good. Okay, you are good to go. Now talking about the network security groups. So when we have network security groups, the idea of this is I have inbound and outbound tables that I need to make sure that I'm allowed or not allowed to basically pass traffic. So I can restrict, okay, the traffic on my VNet that I can attach network security groups to two resources, a subnet or an individual NIC, so a network interface. So let's imagine it is on the subnet. So if it is on the subnet, for me to enter on that subnet and I'm doing an inbound to a VM that's inside that subnet, that VM1 that you see over there, so I need to have this table. This table needs to allow the traffic that I want to do. Imagine I'm doing 3389, so an RDP connection. So that NSG2 that you see in the diagram needs to allow you to go. Then I still have an NSG1 attached to the NIC of the VM. Then again, that NSG also needs to allow me basically the navigate as an inbound rule, the 3389, from where the source and to the destination. And then if that allows, okay, I get it, and I can do an RDP connection. If one of those do not allow, you're not allowed, period. Okay? And of course, the opposite is the same. There will be outbound rules, so I can deny like internet traffic from that VM and things like that. If you see in the diagram, I also have a VM2. That VM2 doesn't have any NSG attached to it. But because I have the NSG attached to the subnet, well, this one will only follow the rules of that single inbound, outbound table that you have there, okay? That's the way that we can do this. What about application security groups? So application security groups within a network service group, I do this to apply a security rule to a group of resources because it's just easier to deploy and scale up specific application workloads that way. I just add a new virtual machine deployment to one or more application security groups. And then that virtual machine will automatically pick up the security rules for that work group. Because sometimes we might have some applications that can span more than one subnet. And so that's the way that's basically an idea of having this a little bit easier, okay, to manage. So I can group my virtual machines logically, no matter what their IP address or subnet assignment are. So that's the difference that we had before. Where in subnet, it's kind of physically, you're just putting them inside that subnet. So you're blocking the range of IP addresses that they can use, etc. So in here, it's not. It's just more a logical grouping that we do. Then what about virtual network service endpoints? So virtual network service endpoints, it's an awesome service because by default, so if you don't use this, Azure services that are designed for direct internet access, like in the diagram that you see over there, like an Azure storage account, if I'm using a virtual machine inside this VNet, like that web server or that database server, so what happens is that they need to go through the internet, and they need to be exposed on the internet so that I can access those services, that storage account. What service endpoints does is that you can connect certain platform as a service services like storage, SQL, Cosmos, Key Vault, Service Bus, Data Lake. So there are just some, there are more. But I can do this directly from my private network subnet. So I can even trim down this so that only connections from that specific virtual network will be allowed. So it's an awesome service that simplifies a little bit security because I don't have any more this exposed in the internet, but also facilitates a better route in terms of latency. So usually you even have latency gains and improvements using this kind of features. So types of virtual networks. So I have a virtual network that is a cloud-only VNet and doesn't have any connection whatsoever to any on-premises network. Or I can have a cross-premises virtual network that has a site-to-site VPN connection or an express route connection and kind of expands this virtual network, kind of expands our on-premises network. So this is basically one of the ways that we can use it. And to be totally honest, a lot of companies today, they're still in a hybrid environment. And so we need to have this kind of implementations in their workload. So this is kind of the second option here, is kind of a more common approach to have today in companies. Then I also have subnets within the VNet. So what is a subnet for my virtual network? So I have a virtual network, and when I create a virtual network, I'm basically creating this, and I define an IP range using a CIDR notation. And then, of course, usually depending, of course, on the range that you choose. But usually you can choose like if you go by with the defaults, okay, you get around 64 to 65,000 IP addresses. That's just too much to manage on its own. So what I can do is I can create smaller subsets of that big range of IP addresses that I have, and we call it subnets to do that. And then those subnets will have smaller numbers in terms of IP addresses, like imagine 254 IP addresses or 50 IP addresses or whatever, depends on the CIDR notations, that you should just choose whatever IP addresses you need. Okay, don't go for 65,000 IP addresses just because you can. Okay, that doesn't make any sense. Then you're limiting other virtual networks to use kind of the same ranges, okay? Because you don't want that, because you can't have two virtual networks using the same range of IP addresses and then connect those two VNets, like using peering, for example. That's not possible. So you have to be very careful when you're planning your network in terms of, okay, this is a virtual network for this, and I will create a subnet here and here and here, and those would be the names. Usually we create a subnet when we have a network, like a workload layer. If I have like something like for a web front end, like we saw before, that should be a subnet. If I have a backend, that should be a second subnet. Usually we do this because all the machines in that layer, they should have the same level of permissions in terms of needs, in terms of network security. So open ports, closed ports, all of this should be the same because all the VMs within are doing the same thing. So what we do is we create an NSG, we put all those inbounds and outbound rules, we associate the NSG to the subnet, and then we don't need to do any more configurations on the VMs. We just need to drop VMs inside. And all the VMs that are inside that subnet, they will fulfill the rules that you saw before. So now let's do a very simple demonstration here, which is let's just start to create a virtual network so that you can see how easy it is to create a virtual network and then just add one or two subnets to that VNet. So from the time that we are delivering the sessions, the Azure portal might have changed, and we need to assume that as normal, because Microsoft is always providing new features, new services, and improving the usability of the Azure portal. So if you see your version of the Azure portal slightly different than the one that you see in the demos that I'm providing, find that as normal. You just need to adapt, and I'm sure it will not be majorly different. So I'm sure that you can handle those changes. So we're here back in the Azure portal, and I'm going to create a very simple virtual network for you guys. So let's just click create a resource, and let's just type virtual network. So there you go, we have it here. Then, the usual overview, I have the plans. I can just check this a little bit, but well, let's just go for create. I need to choose a resource group, so I choose the AZ networking, and I need to provide a name for this. I'll just call it VNet videos demo. This should be okay. Now we need to be careful with the region that we choose. In my case, I want to choose West Europe because now in the future I want to create virtual machines and other resources that need to live in West Europe because of privacy issues. I have to have them in West Europe. Let's imagine, this example. I'm just saying this because a VNet doesn't span across regions. So you have to put a VNet in just a single region. If you have those kind of scenarios, we're going to see it later. Well, we can have two VNets and then connect the two virtual networks, like using peering, for example. So in here, I'm going for IP addressing now. So I'm in the IP addressing tab. This is the IP addressing that I'm using. So here you can see it. I can add more if I needed more. I'm okay with this one. And then you just provide me here, okay, some of the subnets. And in my case, I can create here and add right away also another subnet. So I can just say, like, for example, front end. So this is the name of my subnet. And now I can do like 10.1.1.0/24. So this is the CIDR notation. And I can also use here service endpoint. See, the one thing that we covered already. So there are several services. I could just say, hey, I want a service endpoint in this subnet for the storage service. Well, I'm not going to do that right now. So I can just do this. I can then select this one, remove this, and then I can add here another one, or better yet, sorry, let me just click on this one. Let me add, okay, this one, because I deleted the other one. And I'm now going to add here another one called back end, and then this one is the one that's going to have the .1 over there. And I could just do this. And if I just review and create, and now if I just create this, you're going to see that creating a virtual network, it is pretty fast. So it doesn't take that much time. See, I didn't even pause this. And there you go. So this is my VNet. You can go to address spaces, and if you want, you can edit this, add more. If I go to subnets, I have the 2 subnets that I just created. And now, of course, I can add more features to this, like DDoS protection, a firewall for this, security also, security center, basically stuff that I see here, DNS servers, and of course, then I can also do peering, and et cetera, et cetera, et cetera. So there's a lot of options now in here to manage our virtual networks. In the overview blade, you can see all the connected devices, so all the devices that are currently connected within this virtual network. As you can see, well, we don't have any yet. That's normal because, well, we just created the virtual network. But now if I want, I can add a virtual machine, and I can add that virtual machine to this virtual network, and it will show up in the list of connected devices in here. So what about types of connections from cross-premises VNet? So when we have a virtual network and we want to connect this with other networks, we have series of possibilities to achieve this. So the first one will be using a site-to-site connection to an on-prem network. So we have our headquarters, we have our on-prem network. We can use a site-to-site connection to achieve this. I can also have point-to-site. And if I have remote workers, they can connect to their basically workloads that they have under the virtual network on Azure, and they can just establish a point-to-site, which is just a software-based thing that they install in their machines, and they can just establish a basic connection to that VNet. I can also use, for example, express routes, and we're going to cover that in a moment, which is a very reliable and basically a private network for you to connect from on-prem to your virtual network too. And I can even do a VNet to VNet connection to other virtual networks. So if I need to do that kind of connection, I can also do that. And we have several ways also to achieve this. I can do a VNet to VNet, which is a VPN connection, or I can also use VNet peering to achieve the same outcome with different capabilities. Yes, for sure. And we're going to check out that. So let's start with the point-to-site connection. A point-to-site connection creates a secure connection between individual devices and the Azure virtual network. This type of connection is suitable when you have, for example, remote workers. Let's just give a more precise example. A worker that is on a conference, it still needs to access some corporate resources. So yeah, we can have it connecting from his own laptop to the virtual network. Or a very popular case today when we have remote workers that they are working from home. So same things, if they need to access corporate resources that exists on a specific virtual network on Azure, so we can also have them connecting through this point-to-site connection. A point-to-site connection doesn't require dedicated VPN device for your workers, so they can just use their own laptop or desktop and establish a traditional VPN connection. It's not like site-to-site where you need to have devices on-prem. In here is just a laptop. It's more enough, and we just need to install some software. So it's very easy to implement this point-to-site connection type. Currently in Azure point-to-site VPN connections, so there are several protocols that are supported. OpenVPN, it's one of them. It's an SSL TLS based VPN protocol that it's a very popular solution because it easily penetrates firewalls, because most firewalls usually they will open port 443 and this will work on that same port. And also this supports a variety of device types. So if you have a Windows user, yeah, this will work. A Mac, Linux, all of those we will be supported OpenVPN. And even if we're talking about mobile devices like Android or iOS devices, they can also be supported with this protocol. Other protocols that are supported, it will be the Secure Socket Tunneling Protocol, SSTP, that's also supported, but only for Windows 7 and later versions. And also IKE v2 VPN, that's also supported. So this usually it is supported for Mac devices and OS X. Usually it's version 10.11 and above that supports this. So also the point-to-site VPN connection, like we saw by the names of the protocols and the technology, all the communications are encrypted with the VNet, and that's a guarantee that no one can listen to the traffic and things like that. So for example, here in the screen, you can see that we have a gateway, and that gateway has more than one point-to-site connection. And still, I'm using the same connection, as you can see here, to establish connection through, for example, a site-to-site. I could just use the same connection. So I don't need to create a new gateway just for doing site-to-site connections. I can use the same gateway, that VPN gateway that we can find on the left. There is just something that you need to understand, is that there is several SKUs for the VPN gateway that will have an impact on the number of point-to-site connections that are concurrently allowed, and also site-to-site connections, and also the total bandwidth that all those connections will share. And of course, if you go to the lower tier, you'll have less connection and a lower bandwidth than if you go to one of the higher tiers. If you see the tiers and you find out that, well, I have a specific use case that I need a little bit more capacity on this, so this doesn't serve me, well, no, of course not. Talk with your Microsoft representative. I'm sure that Microsoft will get a solution for your case. What about that virtual network gateway? So basically the virtual net gateway, it's where we have and where we send encrypted traffic between Azure and the on-premises, because that's sent through the internet. So all that encrypted traffic is sent there. And then the gateway contains all the routing tables and gateway services, so that from my machine, from my laptop, for example, I can reach a virtual machine that is on the Azure virtual network, which is another network. So I have to have those routing tables to understand how I reach there. Of course, for the users, look, and even if you have a VM connecting, that's totally transparent. So you don't have to create anything. It's not something that you need to use or something like that. It's totally transparent. So talking about those Azure VPN gateways, they are deployed in Azure networks, and to enable the connectivity, it's where I do point-to-site connections. I need to connect to the gateway, If I do a site-to-site connection, the same thing. So I also need to pass to that VPN gateway. Like I said, we have different SKUs. Different SKUs have different capabilities. And that gateway usually takes a while to create. In reality, that VPN gateway behind the scenes, it is not one, but at least two virtual machines that then will take care of all the routing tables, like we said, etc. So all of this, it will be taken care by the gateway. And it's two virtual machines so that we can have a high availability, so that you don't need to configure any of that, and you don't need to maintain it, update it, etc., because it's managed by the vendor here, which is Azure. When we are designing a network and customers tell us that, hey, look, we have something on-prem, and we want also to connect our on-prem network with the network that we're going to have on Azure. So usually when I'm doing this, I like to have topology that is called a hub-spoke network topology, because this allows us to structure the workloads that are carried out by your servers. It uses a single virtual network that you see there in the middle of the diagram as the hub, which is also connected then to my on-premises network through either a VPN or through ExpressRoute. And then on the right, you have the spoke networks that are basically other virtual networks that are paired with a hub, so that when I have something in my basically on-prem network that needs to reach one of the spokes, it will use the gateway to connect to the hub virtual network, and from there it uses the VNet peering to reach where I have workloads in my virtual networks, that is in the spoke. Benefits of this is the use of the sharing and centralized services on the hub. It will reduce the need for duplication on the spokes, which can, of course, reduce costs, because you don't need to create a gateway for each of the virtual networks. So it will help on that. Also, because subscription limits are overcome by peering virtual networks. Again, there are limitations on numbers of services and things like that we can't have, and one of them is how many network gateways that you can have. So yeah, you have to be careful with that. And if you have really a lot of different networks, you might get in trouble with that. And this one here, well, it just don't have that limitation anymore. So in terms of architectural components, so you see here this diagram where I have an on-prem network, I have this hub network where I have a management subnet with jump boxes. I could use also Azure Bastion for this. I have like a DMZ subnet where I can put here some machines. I also have my Active Directory subnet. So I'll have there two virtual machines in an availability set to serve as Active Directory domain services. That it is, of course, basically replicating, and they are like secondary domain controllers from the primary that, let's imagine, it is on-prem. And their communication goes through, the ExpressRoute gateway that you see over there to the gateway on-prem. Then I have on the right two other virtual networks that also have a jump box subnet to do the management, and they also have workload subnets. They could be web servers, they could be SQL databases, API servers, you name it. So we could be whatever we need them to be in order to host our workloads. Deploying VPN gateways. So when we want to connect our data center to a VPN gateway, we need to have, of course, a gateway subnet that is really called gateway subnet. So you need to have that pre-created. And when you create your virtual network gateway, you also need to add an IP address, which needs to be a public IP address, because your VPN device on-prem needs to connect, to that IP address. And then you need to also establish what is the network gateway. So that connection that you see there, that object, it is basically a logical connection to the local network gateway that you also need to create that as an Azure resource. So the local network gateway configuration, it will be this IP address, etc. That's the IP addresses that the range of IP addresses that you're using and things like that. So that he knows, okay, that when someone wants to connect with an IP address with that range, hey, you need to use, of course, the gateway to reach it. So that it builds the routing tables that we are talking about. In terms of high availability scenarios, so we have a lot of them, and usually we start to have the active standby one. This is by default, so VPN gateways are deployed as 2 instances, like I said before, in an active standby configuration. So even if you only see one resource in Azure, which is the VPN gateway, when there is planned maintenance or unplanned disturbances that affect the active instance, the standby instance will automatically assume the responsibility to connect without any user intervention. So there is no intervention from the administrators to do that. We can also have active. So with the introduction of support of BGP routing protocol, I can also deploy the VPN gateways in an active configuration. So when we use this, I assign a unique public IP address to each one of the instances, and then I create separated tunnels from on-prem device to each one of those IP addresses. And then I can extend the high availability by deploying even additional VPN devices on-prem too, because if you have this, but on-prem you only have one device, it's better because you have high availability on the Azure side, but you don't have it on-prem side. So it's always a good point to improve there. I can also use express route failover. So another high availability option is to configure the VPN gateway as a secure failover path for express route connections. So usually express route circuits, we're going to talk about them, but they have already built in resiliency. But of course, even if they have this, they are not immune to physical problems that will affect, let's imagine, the cables that deliver the connectivity. So if you have a problem with that, this one can be a good failover for those cases. And then I have the last one, which is the zone redundant gateways. So in regions that support availability zones like East US, West Europe, North Europe, so VPN and express route gateways, they can be deployed in a zone redundant configuration. This will bring resiliency, scalability, and higher availability to the virtual network gateways because you're deploying gateways in an Azure availability zone, so physically and logical separated gateways within a region. So one goes to one zone and the other goes to another zone, and of course you protect this against power networking failures, okay, and cooling also, because each zone has its own independent one. So this is what we have, but what about express route? So the idea of having an express route connection is that express route lets you seamlessly extend our on-prem network into the Microsoft cloud, and this is not only for Azure, it is also for Office 365, Dynamics 365. And the idea is that this connection that you have here, it is private. And if you see there, you have your customer network on the diagram, then you do a connection to a partner edge. So there's a partner involved that usually it's a local internet service provider, enterprise internet service provider. And then that partner has to have redundant circuits to the Microsoft Edge. So basically to the Azure data centers. And then over there, you can connect this with your networks. You can connect this with Office 365 and other platform as a service services. So that's the big advantage that we have this, and this is a private connection. You can get higher bandwidths and dedicated connections. So when we say, you have 1 gigabit, you really have 1 gigabit because you're not using the internet, so there's no contention on this. Again, basically talking about basically express route, I have several models to deploy this. So I can do Cloud Exchange co-location, where there is co-located providers that can normally offer layer 2 and 3 connections between your infrastructure okay, which might be located in that co-location facility and to the Microsoft Edge, basically. I can do point-to-point Ethernet connection. So again, provides layer 2 or 3 connectivity between your on-premises site and Azure. Okay, so you can connect your offices or data centers to Azure by using the point-to-point links. This usually also passes through the partner edge. And then I can do any-to-any connections, okay? So with any-to-any connectivity, I can integrate my one with Microsoft Azure. So I already have that one over there where I have all the services connected, because I have like a headquarters, and then I have several branch offices, and then I can use this, okay, to connect. So with any connection, that one providing offers layer 3 connectivity. A great example is, imagine that you have MPLS connectivity that's connecting the branch offices with all the sites. I can just basically plug in an express route connection, and it will just act as another location of my private one over there. So it's a pretty cool feature because it doesn't require that much change on the network types. I can also talking about one. So one is also a service that I have currently on Azure. So I can do an Azure Virtual One, which is a networking service that provides basically optimized and automated branch connectivity too, and then through Azure. So Azure services, Azure regions will serve as hubs that you can choose to connect your branches to. I can leverage the Azure backbone to also connect branches to enjoy the branch to VNet connectivity. I can do Azure Virtual One, bringing together many Azure Cloud connectivity services like site-to-site VPNs, express routes, point-to-site user VPNs into just one operational interface. It's a pretty cool service that I currently have in Azure. Connect services by using the virtual network peering, so using peering. So this has become a very popular approach, especially when I need to connect to different networks. So I can just establish a peering connection, and I'm going to do a demo on this, and you're going to see how easy it is to set up a peering connection. There is no charges on devices because there is no devices to configure like I have when I do a VNet to VNet, which I need a gateway in one of the VNets. I need a gateway in the other VNet. In here, we don't have this. But if you do VNet to VNet, that's an encrypted network. Peering, it is not encrypted. But peering, it will use the Microsoft backbone. So there's no need for that level of encryption. If you need that encryption, well, we can always use the VNet to VNet approach. So that's always nice. I can have two types of peering. I can do virtual network peering, which is networks that are in the same region, or I can use global virtual network peering, which I can connect regions that are in different networks. Like I have one network in North Europe, another one in West Europe, and I can use this. The example is Europe, but you can do this from West Europe to the United States, to Asia, whatever. There is no limitations on the regions that support global VNet peering. There is a big catch, but this is more like Network 101, is that if you want to connect two networks, you need to be careful so that your address spaces do not overlap. But look, this is not Azure, okay? This is, like I said, is Network 101, because if they clash, well, they can't basically be connected with each other. And in here, you see, basically, if I have that 10.0.0.0/16, and I have another VNet with the same range, it is not possible. Even if it's just clashed partially, it is not going to be possible to do the connection, okay? The second one, as you see, they're totally different IP addresses, so of course, it is possible on that one. This leads me to an advice, a big advice. If you're going to do this in your company, before you start to do networking, stop and do an analysis on your current network infrastructure today. And then check out what you have, check out all the ranges that you're using, and then plan wisely your Azure VNet. because you can't clash stuff from on-prem, so then you can't do basically a VNet, like using a site-to-site connection or a point-to-site connection, things like that. And of course, you even in just Azure, you also need to plan wisely, because it is very easy that someone in your company will just create another VNet that is using the same range of IP addresses as some other VNet somewhere. You have to control that. This is why usually companies have a network department, and there's a group of people that just takes care of network. So they will be the best persons to do and to plan and take care of this. So now let's just do a demo, which is exactly about this. So let's configuring VNet peering. Okay, so we are back in the Azure portal. So let's set up VNet peering between two virtual networks. So let me go to resource groups. I have here a resource group where I have already two virtual networks, and I just want to peer one with the other. They already have been careful so that the IP addresses do not clash, and so they do not overlap with each other. So I'm going to one of the virtual networks, and under settings, I have an option that is called peering. If I choose this one, well, now the only option that I have, just add a peering. So now I can just give you a name for this, and let's just give you like VNet, okay, to VNet, let's just say demo. Okay, let's just call this. Usually we give names that is like peering from that network to that network name, but my network names here don't match that well, so let's just do this. Now I have to say which ones I want to network. So what is the network that I want to peer this one with? And of course, this is the one. I have to provide here the other name, because this is the peering from network to the demo one. So when you do this, you're going to see that in the notifications, you're going to see two notifications for this, because you're doing the peering in the two directions. In reality, it's two peers that you're doing. And then I have some extra configurations about the peering. If I allow virtual network access from one network to the other, in my case, I just said, yeah, I will enable this. And then you can also configure forward traffic. I'm going to see this in a further slide, but it's just if you allow forward traffic from one network to go to the other, and if you also allow here the gateway address. I'm just going to press OK, and you're going to see that now, like I said, the two peerings. So one said, oh, I'm peering from one network to the other, and then the other one is the inverse. Okay, so for the network 2 to the demo network. And now if we wait a few seconds, you're going to see that the peer connection, it will be established. So there you go. And I'm in here and I'm connected. So I'm in the demo network. Now if I go to the other network, and if I go to peers, you see, there you go. I also have, okay, here the other peering. So the peering also shows up in here. And this is how easy it is to create network peering. And in my case, the two networks were in the same region, but they could be in different regions. There is no problem with that today. So we can do that with no problem whatsoever. So configuring name resolution. So Azure provides DNS, and also you can also use the scenario of bring your own DNS server. So basically Azure by default already provides the DNS resolution. This is a highly available service. You don't need to create like a virtual machine to host your DNS servers. You don't have to worry about anything on that end. If you want to bring your own DNS servers, yeah, you can also do that. So you need to create a virtual machine, host a DNS service, for example, a domain controller from Windows Server. They can also run the DNS server and take care of the DNS queries for its own domains, and then forward all the other ones queries to Azure. So all of those two scenarios are possible. As you can imagine, I will prefer, to be totally honest, to use the Azure DNS, because I don't have any machines to manage, and I tend to like that approach, to be honest with you, because there is not that much business gains in managing your own DNS, because it can't be just one machine, by the way. You have to have at least more than one machine so that you can have some kind of high availability. But basically, that's the idea. We can do that. Configuring some name resolutions, some of the most common scenarios, and then some of the solutions that we can use. So name resolutions between role instances or virtual machines located in the same cloud service or virtual network. Azure DNS will just work perfectly on this. You don't have to set up anything. If you have name resolution between role instances or VMs that are located in different virtual networks, customer managed DNS servers forwarding queries between VNets for resolution by Azure DNS, that can be a solution. Also, resolution of Azure host names from on-premises computers. So I can forward queries to a customer-managed DNS proxy server in the corresponding VNet. Okay, so that's also a way to this. Then that as proxy forwards the queries to Azure for resolution. Those are like probably the most common ones. But yes, there is some use cases that, yeah, I need to have my own servers, especially when we're talking about having a hybrid environment and things like that. But it will tend to the part where you can start to ditch some of those servers for some of the scenarios and then use the managed Azure services. One of those services is for private DNS zones. And if you want to have a private DNS zone, this will contain the DNS interest for a domain. And then you can even attach and associate this with a virtual network, and that virtual network will do auto registration of all the NICs that you associate in that VNet with this private DNS, so that all your devices will get a .domain entry over there, and you can have that as a host name and not rely on the Azure host name. So you can use this to solve that problem. So it's a pretty cool service. So let's just do a demo exactly on this, on how can I create a private DNS zone. So we're here in the Azure portal, and we're now going to create a private DNS zone. So to do this, let me just click create a resource, and let's search for private DNS. And well, there you go, private DNS zone, exactly what I want. I will click create. I just need to do the standard stuff around subscription and resource group, where I want this resource to be hosted. And now, what is the domain? Okay, for my zone, let's just do contoso.com. As you can see here, so this location that you see here, it's the resource group location. It's not the resource, the private zone, because the private zone, it's basically a global service, and because it is a global service, they cannot have, they're not bound to a specific region. So now we're creating my private DNS zone. So let's just wait a second to see if this finishes to create. There you go, it is done. I'm going to my resource, and now you see in here I have here my private zone, contoso.com. I can add record sets for this. It's the standard record set from a DNS zone. So I can just say www.contoso.com, and then it's like a CNAME record, and you just put an alias there. So basically we could just do things like this. A great setting that I have here, it is this virtual network links. So I can go here, I can click add, and now I can associate this. And let me just see here, demo VNet, for example. I can click here and I can say, hey, I want to associate this with a VNet, the VNet videos demo. And I can even associate this configuration, which is enable auto registration, so that when you add virtual machines, they will be auto-registered in your DNS zone. So records will be added for their IP addresses. It's pretty cool setting that you can do. Just press add, OK, and now we just need to wait a few seconds again. This will be added into the setting here, and then this private zone will start to do auto registration of devices for that virtual network. There you go. So it was created successfully, and we have here and the enable auto registration. It is enabled, and this is how easy it is to set up a private DNS zone. So let's talk about public DNS. So Azure has a DNS service that I can create public DNS zones. And then I have basically a bunch of name servers. Of course, if you have your registry for your domain, and let's imagine in the screenshot here, we have the contoso.xyz domain. I just needed to go to my registry and add those name servers so that every request it is forward you to those name servers, which is the name servers on Azure. Then within the DNS zone resource, I can just add the record sets. So www, it's an A record for what IP address? Oh, that IP address that you have there. So, and I could do something like this. And then if you do like a NS lookup, like you see over there, for that, you could just get, okay, that, well, just basically forwarding you to the 10.10.10.10 IP address. Of course, well, it could be a public IP address where you could reach, but this is kind of the idea of the things that we can do with public DNS. I can also, when I add a record set, I can also add Azure IP address resources, so you don't need to do only this for IP addresses itself. You can also bound this to Azure resources. It's pretty cool what you can do with this. So now let's just exactly do a demo on that, and let's see how can we configure public DNS, and let's create some resources over there. Okay, so this is a DNS zone, a public DNS zone that I have for the azcontoso.com domain. This is a domain that I usually use for several demos that I do, and very similar like you saw on the private DNS. So in here I can just add some records, some record sets. And I can add, like, for example, let's imagine cdn.azcontoso.com, cname, and then the alias will be like my cdn endpoint.azureedge.net, and I could just add, okay, basically something like this. I can add other record sets. Let's see, www, for example, and it is an alias record set, okay, in this case. And now I can bound this to a specific Azure resource. I could select here, for example, a specific subscription. And now I could bound this for an IP address. And I could just do that VM workstation IP address. That's an IP address. It's a public IP address. And I could just do this. If that IP address changes, well, this will be updated because this is not bounding with the number of the IP address. It's bounding with the resource IP address, which is the Azure resource. Okay, it's not the number 1, 2, 3 something. Okay, no, it's not. It's the resource itself. So if you just do this, okay, it will basically add this record to this, basically to that resource. So you see there. So the alias resource type is a public IP address, and then that's the name of the resource. If the number IP changes, well, this will be updated. It's pretty cool what you can do with this. So it's time to do a 2-minute break, and after our break, we're going to talk about implement Azure load balancing. Welcome back. So let's start to talk about implement Azure load balancing. So we can use Azure Load Balancer. That is a service that we have, a totally managed service, by the way, that we have on Azure. So we can distribute traffic across multiple virtual machines. So we use Load Balancer to scale applications, to create high availability for our virtual machines and services. Load balancers use a hash-based distribution algorithm. So by default, a 5-tuple hash is used to map traffic to the available servers. So to do this, that 5-tuple hash basically is the source IP, source port, the destination IP, the destination port, and also the protocol type. That can be TCP or UDP. And in Azure, we have the Azure Load Balancer as a managed service, like I said, that it's a layer 4 load balancer. Configuring a public load balancer. So by the way, we have a public load balancer, and of course we have the internal load balancers. We're going to have a public IP address here, and then I can do my distribution method by using the 5-tuple hash. That's the default distribution mode for the load balancer. But I can also choose the source IP affinity. In this case, distribution mode is also known as session affinity or client IP affinity. So to map a traffic to the available servers, the mode uses a 2-tuple hash from the source IP and the destination IP, or a 3rd-tuple hash, so source IP, destination IP, and the protocol. The hash will ensure that the requests from a specific client are always sent to the same virtual machine behind the load balancer. That is needed in some cases that your applications are just not prepped for a multi-instance environment, so you always need that connections from that customer will always go to the machine, because you have, like, I don't know, variables in cache or cache that are in memory and things like that. So you really need to have the environment configured that way. I can also use an internal load balancer. So to do this, the idea, as you can see over there, so I have the first one, it's a public load balancer. I balance the load for those three virtual machines that consist of our web tier. And then I have our database tier, and those virtual machines to connect to our database tier, they are using an internal load balancer. When you create a load balancer in Azure, you don't specify, I want to create an internal load balancer, or I want to create a public load balancer. You create a load balancer, that's it. What becomes an internal or a public load balancer is the IP address that you assign to the front end configuration of the load balancer. So in this case, for an internal one, you will assign a private IP address to the load balancer. And then you need to configure your backend pool. And then when you configure your backend pool, you're going to add, in our case, those virtual machines that correspond to that SQL database tier that you have over there. Then, of course, you also need to configure probes, and then probes will also verify if all your instances are running or if they are running into issues, so that they can remove the non-healthy instances from the backend pool. Let's just jump into a demo. And we're going to create a load balancer, and you're going to see how can we configure. So now it's time to create an Azure load balancer. We're back in the Azure portal, and if we go to resource group, I have here a resource group called AZ Videos, where I have some resources created here. So I have a virtual network, and then I created 2 virtual machines in that network. So you can see here VM01 and VM00, that they are both in this availability set. All the other resources are like network security groups, the NICs, disks, that they're like the associated resources for the virtual machine infrastructure. If we go to the virtual network, so we can see Yeah, great. I have two devices here connected, both in the front and subnet. Talking about subnets, you can see here I have a front end subnet and I have a back end subnet. But now, those two virtual machines that I have here, they are instances of IIS, and I have my web application deployed to both, so I need to create that load balancer. So let's get back to the home page, and I will click here to create a new resource. And of course, now I'm just going to type load balancer. So load balancer, and there you go. I can choose this one. Yeah, load balancer from Microsoft. That's the one that I want. I click create. Now the usual things like the subscription and resource group. Then I have to create here a name for my load balancer. So I'm just going to do load balancer demo, for example. And it's not in this region, so this is a common mistake that people will do, is they create the load balancer in a different region than where they have the virtual machines, and of course that doesn't work, okay? Because you can't find the VMs when you're adding the backend pool. So I'm doing this now, and now I just need to provide your IP address name again, LB demo, and I'll just put IP. Okay, then I can add tags, but I'm not going to do that. It's just a demo, and I'll just click create. So now my Azure load balancer is being created. So let's just wait a few moments for this to be created, and there you go. See how fast this is now? And I'm going to my load balancer, and now it is pretty easy to set up the load balancer. So, but it's still some work to be done, okay? So one of the things that I have to do is going to here the front end IP configuration, check, okay, yes, I have here my load balancer, that's okay. If I go to the back end, of course, I don't have anything in my backend pool, which it's the expected outcome for this. So I need to add here a new backend pool. So let's just put backend pool demo, and I now need to select, so which is the virtual network. It's this one here, VNet Western Europe demo, and IPv4, and then I need to associate to what? I can associate virtual machines or virtual machine scale set. Well, in our case, it is virtual machines. And now I click add, and I can select which virtual machines I can add. And I can just add those two at once. So both of them are going to be added, and I'm just going to click add. And now those two virtual machines are being added to our backend pool. So let's just wait a few seconds for this to be added. There you go. So we have our backend pool here fully configured to our private IP addresses. So that is good. So now I can add here some health probes. And I'm just going to do here, so health probe demo. Yeah, it's going to be TCP, port 80. Yeah, everything is okay. I agree with all of it. So it's creating our probe. So let's just wait a few seconds for our probe to be created. And there you go. We have a probe. Now that we have a probe, I can go here to my load balancing rules. So let me just refresh this. It's still updating. Okay, so there you go. So now I can add. I just needed to refresh this. So let me add here load balancing rule. So load balancing rule demo. I'll just say, yeah, it's an IPv4, port 80. The backend can be also port 80. That's fine. You can also tweak here the system persistence. So if you want client IP and protocol, that will be fine. And with this, you're basically just configuring how your load balancer will behave in terms of doing the load balancing. So I'm just pressing OK, and that's it. Okay, so right now, this will take us also a few seconds for the load balancer to kick in. And basically, then after this, we're going to have a load balancer up and running. It's not only about load balancers in Azure. We also can do application gateways, which is a load balancer, but it's what we call an application delivery controller as a service that offers layer 7 load balancing capabilities. It has a different way of working as a traditional load balancer because, like I said, this is layer 7 load balancers. The traditional load balancers, they are layer 4. So this is protocol specific. In our case here, we're talking about HTTP, HTTPS protocol. And what we have, as you can see here in the picture, so I have my browser in the client. I go to the application gateway front-end IP address, and I will have an HTTP, HTTPS listener. Then, based on a set of rules, will forward you to a backend pool. That backend pool can be virtual machines on an Azure virtual network, can be also a virtual machine scale set, or can even be an on-prem servers. I'm sure you remember when we demoed the scale sets, I could create straight away from the UI a load balancer or an application gateway. If I already had the application gateway, I could configure it in the scale set. So it's one of the options that I have. And in the end, what this does is web traffic load balancing to our applications. But then the great advantage that I have with this is that I have a huge, rich set of rules and features that I have in this one that I don't have in the traditional load balancer. One of those is path-based routing. So path-based routing basically enables you to send requests with different paths in the URL, and they will basically be associated with a specific backend pool. And you see over there that if I have a path called contoso.com and then the path is /images, hey, you go to that server pool that you see over there. If you go to video, well, you go to a different path. The big example that you have with this is why this is so cool and why this is a thing and a feature that we need. A lot of people ask me that. Well, imagine that those virtual machines that you have in the video pool, okay, they can be specific virtual machines with specific configurations that are optimized to handle video streaming. And when you do /video, it's where you're starting to do all the video streaming stuff in your application. So if those machines can handle video streaming in a better way than the ones that are doing images, well, it's obvious the advantages that I can have with this. So this is why this is so cool and why I really love this kind of features. Another feature that I have is the multi-site hosting. So I can use a single application gateway and I can basically do multi-site hosting. So along with path-based routing, multi-site hosting, there is other capabilities that I can also use, like redirection. For example, I can say, oh, if you're getting this, okay, redirect this to another site. Rewrite HTTP headers. So if you have an HTTP header allowing the client and server to pass additional information with a request and a response. Also having a custom error page. So application gateways allows me to create custom error pages instead of displaying the default error pages that you have on your application. So if imagine that I have like a huge problem in my backend pool, but still my application gateway still survives, well, at least I can still show some error pages in my end. It's better than nothing for sure. But yeah, we can have this. And also, I also have a WAF there. This also does stuff like SSL offloading. So there is like literally a lot of features that I can have. I have like some of them in here. Like I have the front-end IP addresses that client basically requests or receive to the front-end IP address. Then I can configure my application gateway to have a public IP address, a private IP address, or even both. Application gateways can't have more than one public and one private IP address, even though. Then I have my listener. So application gateway uses one or more listeners to receive the incoming requests. So a listener accepts traffic arriving on a specific combination of protocol, port, host, and IP address. And then each listener routes that request to a specific backend pool of server, following the routing rules that you specify. By the way, a listener can also be a basic or a multi-site one. A basic listener only routes a request based on the path of the URL, when a multi-site listener can also route requests using the host name element of the URL. The listener also handles the SSL certificate. So if you can see over there for SSL offload, so that means that all the traffic between the application gateway and the clients, it is going to be encrypted using an SSL, traditional SSL TLS certificate. But for the basically all the backend pools, it's going to be unencrypted. So this, you're just putting the effort of encrypting and decrypting data in the application gateway, and you're not putting that on the individual virtual machines. Then you have the routing rules over there. So those rules bind that listener to the backend pool. A rule specify how to interpret the host name and path element of the URL of a request and direct to the appropriated backend pool. Routing rule can also associate a set of HTTP settings. These settings indicates whether and how traffic is going to be encrypted between the application gateway and also the backend servers if you need to do so. Talking about routing. So routing in Azure, it is pretty cool because usually we have, and you can see over there in this screen, a bunch of system routes. So if I'm in that virtual network and I'm inside one of those VMs in the web app subnet, and I want to connect to the SQLDB VMs on the other subnet, by default I can just do it. I don't have to do anything because that traffic is controlled by using the system routes, which are assigned by default to each subnet in that virtual network. So I literally don't have to set up anything. But sometimes you might want to create routing tables and then override that. And we're going to see that in a moment, that can be very useful, especially when you're using, for example, and you want to basically track down traffic that goes from one system to the other. So you can create an NVA, so like a network virtual appliance to monitor that traffic. But first, let's talk about another service that's called Traffic Manager. So when a client attempts to connect to a service, first it resolves the DNS name of the service as an IP address. Then the client then connects to that IP address to access the service. Traffic Manager, what he does is that he uses the DNS to direct clients to a specific service endpoint address based on the rules that you have done on the Traffic Manager routing. So you have a bunch of routing methods and you have to configure one, and based on the one and the rules that you set up, this is what is going to happen. So clients connect directly to the selected endpoint. So they don't go through the Traffic Manager like we're talking about, like a load balancer. That's not what happens. Traffic Manager isn't a proxy or a gateway. Traffic Manager doesn't see the traffic that passes between the clients. No. Okay, it just gives clients the IP address where they need to go. Just tell the hey, you just need to go there, and that's it. And then customers go directly to the endpoints. They don't need to pass through the Traffic Manager. So I need to create a Traffic Manager endpoint, and I have like several types of endpoints. I can have Azure endpoints. It could be like VM. It can be cloud service, a web app. So all of these are examples of Azure endpoints. I can also have an external endpoint. So I can create a Traffic Manager and using a routing method that's called, for example, priority. and I say that, hey, every time that you try to connect, just go to that IP address. It's an external IP address, and it's our public IP address from one of the services that we are running on-prem. And he goes there, and he just connects to that one, and that's it. That's the priority number one. In case of that one, it is not working, for example, I can have a second priority rule there that says that go to this web app. And then, of course, I need to have basically a copy of that web application running on Azure Web Apps. And that's the service that I'm going to reach. And that's the service that I'm going to use in case of the first one, it is not working. So that's kind of using external endpoints. Then I can also do nested endpoints. So they're a combination of traffic manager profiles. I have a traffic manager profile that can call another traffic manager profile, and then that one will have another set of endpoints. I can do that. So there are several different types of routing methods here. So I can have weighted routing, I can have performance, geographic, multi-value, subnet, and priority. Let's just check some of them. So this is the weighted routing. You choose the weight that you want for each one of the endpoints that I have. And in here, you see I have 3 endpoints. One is called region A, test A, and then the last one is region B. So what happens in here is that region A, I put it a weight of 50, test A 5, and region B 50. This is not percentage. A lot of people think that, oh, yeah, this is percentage. No, a weight is basically an integer that goes from 1 to 1,000. But basically, that's it. And of course, then, he calculates this and he scales this to kind of a percentage, like X percent of the traffic goes to one and the other goes to the other one, for sure. So what happens here is that I'm in the browser, I do a DNS query, I go to my DNS service, and my DNS service points to the traffic manager. Okay, great. Traffic manager, based on the request from where I am, based on the routing method that I have here, checks and see, well, region A is degraded, so it's not an option because it's not working properly. I detected that because I have an integrated probe. And then I have test A that you have 5 in weight, and you have region B that has 50. There is a great margin of probability that you're going to be redirected, to region B. And then, you get to region B and you go directly to region B, because Traffic Manager, as you see there in step 3, what you do is just do a DNS response to the browser saying connect there. And that's what it does. It just goes there and just connects to that one. That's it. There is no traffic passing through the Traffic Manager. Then we have the performance. That the steps are kind of the same, but what it does, the performance, is that it's going to choose the best endpoint to use based on internet latency tables. So you have there, your IP address is within the range that you see there, 8917.0.0/16. So your IP address is in that range. And Microsoft has the internet latency table that says that, well, West US, you will take 15 milliseconds, North Europe, 75, and then East Asia, 150. And of course, you should be directly to West US, for sure. But, oh, wait, West US, it's also offline, so it's not working. So in this case, well, the second best one and the best that is available, it is North Europe. So, that's the one where you're going to be redirected. This is like super cool to use, to be honest with you. Another one is the geographic routing. So this one here, what I'm doing is that I'm saying that I have a bunch of endpoints. And what I'm saying is, well, if traffic comes from Germany, and again, Microsoft detects and he understands where stuff is, you go to endpoint 1. If traffic comes from Mexico or Asia, you go to that nested profile, and then it's another traffic manager that has priority 1 and 2. Basically, it's what it has. And then if it comes from all around the rest of the world, well, you have that endpoint 2 over there that's like where everyone else is going to be. So you basically isolated traffic that comes from Germany and then Mexico and Asia in the same nested endpoint, but still you're still isolating a little bit that. And all the other countries on the world go to endpoint 2. So this is what you can do with this. But let's just use exactly this one. Let's use the traffic manager using geographic. And I'm going to do a demo. How can we implement this in Azure Traffic Manager with web apps? Now it's time to create a traffic manager and create some basic rules so that we can forward some of the traffic to one compute capacity and other to another compute capacity. So let's just start to see what I already have pre-created here in a resource group. So I already have a resource group ready for us. It's in West Europe, this one. And the only thing that I have here, it is pretty easy. I just have a virtual machine created in here called VM USA that is hosted, as you could see there, in the USA. What I'm going to do is I'm now going to create 2 Azure web apps, and I'm going to host one in West Europe and another one in East US. Then I'm going to create a traffic manager that will balance the load based on the geography of the requester. So if it is coming from Europe, it goes to the European data center. If it goes from the United States, I'm going to forward it to the web app in the United States. So let's just close this and let's go to the home. Let's create a resource and let's start to create here a web app. So I go to web app, click create, and now just going to tell it and just go to that place. That is fine. I'm going to do easy traffic manager demo. Let's just put Western Europe like this. It's going to be code, that's fine. It's going to be .NET Core 3.1. It's going to be a Windows. I want Windows as the host, and I'm going to select West Europe. I'm also going to create here a Windows plan. So this is the app service plan. It's on the standard tier, which is okay because that's the minimum that I need to have in order to be able to attach this to Traffic Manager. But I'm just going to change this, and I'm just going to put here app service plan and dash Western Europe so that I know what it is. Then on monitoring, this is just a demo. So I'm going straight to review and create. I'm not going to add any monitoring to this. And I'm going to create my web app. So now my deployment is in progress. I'm not going to wait for the deployment to finish. So I'm going again straight to home. I'm going to create the other web app. So there you go, web app, create. So I'm going to create the web app that is going to be hosted in somewhere in the United States. Okay, so it seems that the first one was already created. So let's see here, traffic manager demo, and then dash US. Again, code .NET 3.1. Now I have a preference for East US, and now this one will be called ASP-US from the United States. Then again, I'm just going to say no to monitoring, and I'm going to start to create this. So when this is finished, I already have 2 web apps. I still need it, like I said before, I need the traffic manager. So let's just go to home and let's just create right now traffic manager. This way everything gets created, all the resources, then we just need to tweak them. So let's just do TM demo. Let's see if this one is available. It is available. Now I need to select the routing method, and the routing method in my case it will be the geographic. This is the one that I want to choose, and I'll just say deploy to that resource group, and I will click create. So right now I already have 2 web apps, and I have also another a traffic manager created. But let's just go to resource groups. Let's go to our resource group, and then we can see our two web applications in here. See over there? So AZTM demo Western Europe, and I have this one here for the United States. So let's just open the European one. And now, well, I could just deploy some code here and just say, oh, Europe, but I'm going to do something else. There's a tool here called App Service Editor under Development Tools that you can click Go, and you can edit the website, okay, that page that says welcome to the app service developer. So basically it says that bit over there. See over there, app service developers, but I can just add something there. So I just added Europe over there. And I don't need to save this. Okay, so basically this is it's being saved automatically. So back at the Azure portal, I go to the overview blade, and if I click browse, you're going to see my app, and it just says over there blah blah blah, and then it just says Europe. Okay, great. That's exactly what we wanted. So I'm back in the Azure portal, and I'm going to my resource group again, and I'm going to do exactly the same thing, but to the United States version of our app. So it's another app that I have. So I go scroll down here, App Service Editor, go. So there you go. I go to this place, and now I just add USA. And there you go. I get back to the Azure portal. I go to the overview blade. And if I click under browse, see now in this website, I see USA. And this is what I have. So I have this one saying USA. And if you see, this is the URL. This one says USA. And I have the other one that has that endpoint, so AZTM demo Western Europe, that says Europe. But of course now, what I want to have is what? I want to have a common ground for this. So in order to have that common ground, I need to go to the traffic manager. Under the traffic manager, I need to go to endpoints, and I need to add here my endpoints. I'm just going to add two endpoints. This one is going to be called Europe, for example. It's not a cloud service, it's an app service. And now I can choose which app service I want. And I want this one here. And I have to do the regional grouping of this. So I'm just going to say Europe. So if the connection coming from somewhere from Europe, that's the endpoint that I want you to go. So this, let's click add. Takes a few seconds to add it. There you go. And now I'm going to add the other one. So let's just call this one USA. Same thing here, app service. I'm going to choose the other app. So the app that I have deployed in East US. And now I can go here, select North America, and I can scroll down to United States. And it's because United States, you can even go to the detail here of the state, which I don't need to do this for this demo. And then I will click add. So now, so there you go. I have the two endpoints deployed here. We have to wait a couple of minutes because the monitoring status here is still saying checking endpoint. So I want online on those two. So let's just wait a couple of minutes to see if this shows up as we want it. And there you go. So now they are both online. So they're both online. So if I use my internet connection here and I connect using this DNS name that I have here. So let's just do that. You can see that, well, I see what I see here. It's the European version of my application. Now let me go to home. Let me go to resource groups again, select this one, and we'll open RDP connection to the virtual machine that I have in the United States. So I'll just click connect. I want to connect via RDP. I download this file, so I can open this file. So let me just connect with this. I'll just press OK. Yes, I want to connect with this. And so if we wait a couple of seconds, there you go. I'm in my virtual machine. I will open here a browser. Let me just close these tabs. And so let me put here tmdemo.trafficmanager.net, and there you go. So you see that in this one, what I'm seeing in here is what? I'm seeing same URL, but I'm seeing the United States version app. So that's the different web app. And I'm seeing this one, well, because this virtual machine, it is hosted in the United States. Okay, and because of that, well, this is the virtual machine. This is the version of the web app that you get. Don't forget, as we saw, there is several other algorithms that you can configure on this. I could just use performance. It will have the same outcome as the one that I showed you. I just wanted to show you the UI when we're adding the endpoints that is slightly different in the geographic, because we have to add that bit, okay, that connections from this place goes that way, so we can control it. Using performance, that is controlled by Microsoft, is just which is the best one in terms of latency. So which is the one that has a lower latency. And of course, look, there are others, priority to and weighted, etc., that you can also use there. But you see, you can see in this demo how easy it is to create a globally distributed application using Traffic Manager and a couple of web apps. What about Azure Front Door Service? So Azure Front Door Service is kind of still a recent offering from the Azure world. It enables you to define, manage, and monitor the global routing for your web traffic. So Front Door works at a layer 7, so again HTTP, HTTPS layer, and uses what we call Anycast protocol for splitting TCP and Microsoft Global Network for improving the global connectivity. You also uses a WAF, so Web Application Firewall, similar what we had for the application gateways that we were talking about, that do centralized protection for your web application. So things like cross-site scripting, things like SQL injections. We have those OWASP rules that they have some rule sets, and some of them are blocked by this, and you can just tweak it. This can also replace Traffic Manager, so also to use this to globally distribute stuff to the cloud. It's an awesome service. Also, not only works for the Azure cloud, also can be the front door, like the name says, for other clouds and even on-premises, and even use a mix. I can have one web app deployed in Azure and a part of that app deployed on-prem, and even using other clouds. Okay, why not? So it's a fantastic service. And in the exam, this is more just making a reference on what it is, etc. They don't go deep into this, but I'm sure this is such a great service that I will say to you, just go deep and research about this. It is a pretty cool service. What about an NVA? NVA stands for Network Virtual Appliance, which is basically a virtual appliance that consists in various layers like firewalls, a WAN optimizer, routers, load balancers, IDE, IDS, IPS. So I have a bunch of different, let's just say, network virtual appliances that I can use in Azure. And they are pretty cool because sometimes, for example, I have the Azure firewall. Let's just talk about firewalls. Okay, I have the Azure firewall. It's a managed service. We're going to talk about it, etc. It's great, but I have customers that they look at the Azure firewall and say, okay, it's a great service for sure, but look, we're already using Checkpoint, Barracuda, Sophos, WatchGuard, I don't know, something like that, and we're used to it, and we want to connect this with the stuff that we have on-prem and things like this. So look, we really don't want to use the Azure firewall. We want to use this, or the Azure firewall is still pretty recent, so it doesn't have all the features yet. And then customers really rely on that feature, and from 4 or 5 of those that are super important for them, there is one that Azure Firewall still doesn't have it. They can't wait for sure, okay? They're not going to wait for this. They need to use something today. So they can go and they can start to use an NVA using Checkpoint, Barracuda, Sophos, WatchGuard, you name it, all the big names in terms of firewall. They already have network virtual appliances in Azure that we can just use. And I can deploy, for example, a firewall into the virtual network in different configurations even. I can put a firewall application in a perimeter network subnet in the virtual network, or if I want more control of security, I can implement even a microsegmentation approach. With microsegmentation approach, what I do is that I create dedicated subnets for the firewall, and then I deploy web applications and other services in other subnets. All the traffic that is routed through the firewall, it is going to be inspected by the network virtual appliance, and then I can enable forwarding to the virtual appliance network interfaces to pass traffic that is accepted by the appropriated subnet. Okay, I can do things like this. And of course, this also relies, and you can see over there that UDR, so basically those are the routing tables, okay, that I can create, and this in conjunction with NVAs, it is pretty cool, the stuff that you can build with this. What about monitoring and troubleshooting virtual network? Because we have all this, we talk about all this is a software-defined network, but of course now we need to be able to monitor this. So we have Azure Network Watcher that helps you monitor, troubleshoot connectivity issues, help me diagnose VPN, NSG, and routing issues. It helps me capture packages of our virtual machines, automate triggering diagnostic tools using Azure Functions or Logic Apps. So I have really a lot of features in the Network Watcher. So some of the features that I have, it's IP flow verify, so I can understand from the traffic from one IP to the other IP where the traffic passes, if it passes, and why, and things like this. I can see the topology view, which is basically the previous slide. So this one can see the topology of your network like that. I can also understand the next hoop. So if I connect from ear to ear, is this passing through an NVA, for example? I can also understand connection troubleshooting, VPN, diagnostics. I can also get NSG flow logs. So there's a lot of interesting information in the Network Watcher. Let's just talk about, for example, the IP flow verify. So IP flow verify checks if a packet it's allowed or denied to or from a virtual machine. So in here, it says that's my subscription, my resource group, that virtual machine, using that NIC, using TCP outbound, and then you just tell them, oh, that's the IP address that I want to connect to using port 443. And using that remote IP address, that remote port, check, and you see, yeah, you're allowed. There's a security rule called allow internet outbound, and I was using that one, and I was successful on that. If you don't, or if you're not success, you'll see there what is the security rule that is blocking you. Then easily you can check the NSGs, and you can see, oh yeah, okay, this is the rule. And hey, if you need to change it, you can just go ahead and change it. You can also see the topology tool. I already told you this. So I can see my VNets, my subnets, and then all the devices and routes that I have in here. Again, useful, but sometimes if you have big environments, it brings you like huge diagrams. On those cases, I really advise you to look for third-party offerings around this. Virtual Network tab. This is also a really cool feature that we have. So it's the Azure Virtual Network Terminal Access Point. And the idea of this is to allow us to stream our virtual network traffic to a network packet collector or analytical tool. So traffic goes, but I can just connect this, and all the traffic, goes to that place, and then, that collector can do some analytics on the data that is collecting and to see patterns or see if something wrong is there, like me sending data to, some places that I shouldn't be sending data, and things like this. So you just mirror, as you could see there, the traffic. You have like the VM production traffic over there, and then this could just mirror that traffic. And let's do a demo about the Network Watcher. So back in the Azure portal, let's see how we can use the Network Watcher to help us monitor our network and also troubleshoot some network issues that we might have. So I can access the Network Watcher by just searching here on top. So Network Watcher. This is the overview blade of the Network Watcher. One of the first things that you should do is to enable this. So this subscription has access to 33 regions, and you know that in some regions I already had enabled, but like East Asia, for example, I don't have it. So if I want it, you just needed to click here where it says enable Network Watcher. I'm not going to do that right now because I'm going to use one of the regions where I already have enabled the service. You can click on topology, and if you select here a resource group and then a virtual network, you can see here basically a small diagram of your topology. But more interesting features will be like package capture. For example, if I want to capture all the packages that I have from a virtual machine, so I can click here, add. I can choose this RG Network Watcher demo. This is the resource group. I have a VM called VM1. I will just say here VM1, packet capture. And I can say where I want basically to place my output. My output will be a cap extension file. You can use like Wireshark, for example, to open these files. You can do this storage account, or you can just put a file inside your virtual machine. I personally prefer the storage account. It's just easier, basically, to access and then to analyze. And if you have hundreds of virtual machines, you can have a consolidated place where you have all this information. Then I can just define here, let's just say 60 seconds here as a limit. And if we press save, so now this is initializing and is deploying this capture picture in our virtual machine. So let's just wait a little bit for this to be deployed. So our package has been added successfully. So basically all the packages are going to be started to be captured during those 60 seconds. So if we now go to our storage account, you're going to see that I will have there, the cap file. So let's just wait a little bit more so that the capture process finishes, and then we're going there to check the package. Okay, so if we go to storage accounts and we select the storage account that I basically configured to get this, I go to containers. You see that I have a bunch of diagnostics. I have a backup here too, and I have this one that says Network Watcher logs, and then this creates a structure in terms of folders, which is the subscription, then resource groups, providers, compute, virtual machines, and then my VM1. And then still under my VM1, I have the year, the month, and the day where this is being captured. And you have here, our capture file. So now, look, I just need to download this file, and I can open this file in a tool like Wireshark, for example, and I can check, all the capture that I have. So if we download this, you see here, so there you go. So more cool tools that I have. So if we go back to the Network Watcher, there is also a tool that I use quite often, which is the IP flow verify. So the IP flow verify allows me to select your subscription, a resource group, that VM. I only have that VM here, it only has a NIC, but if you had more than one NIC, you could do this. And now I can just say here, okay, what is the direction of the connection, the remote IP, the local IP, and the ports. Well, let's just see if I'm trying to do like a call to a DNS server, and imagine that, I should have done outbound. So let's just check outbound. Let's just check outbound again. Okay, so because inbound it is blocked by default, and you see here, okay, yeah, you were allowed to do this, and I'm like, oh, I still have a problem connecting somewhere. Well, probably the problem will not be reaching, okay, the DNS server. It should be something else. So you have to be careful with this. Imagine that I have now like an inbound connection. Another issue. I have like, so imagine that I'm using 120 from this IP address. I just type it a random IP address in here. People are trying to connect through port 443, and if we check, they're not basically getting access to our web server that we have on our virtual machine. And then we need to find, okay, why, and you have here, oh, you have a security rule. So this is here, it's an NSG that is locking the traffic. So this is just two examples of things that I can do with the Network Watcher. That is so much more to explain. Also usage and quotas, NSG logs. There is really much more on the Network Watcher. So now it's time to have some quiz questions. So our first question is, you're deploying a multi-instance workload to several Azure virtual machines. Your users will connect to this workload via a VPN. You need to make sure user connections are spread across different instances. So what solutions can you use? And we have here to choose two options. So we have, the first one says public load balancer. It's an internal load balancer, application gateway, traffic manager profile, or an Azure content delivery network. So if you see here, the idea of the question is, so I have several VMs somewhere, okay, and I have a VPN connection. So my internal users on-prem, they're going to use that VPN connection to connect to those virtual machines. But I need, of course, to have just one endpoint. So we can do that with what? I can do that using a load balancer, and more precisely an internal load balancer. And then I can also do the same thing, okay, because it's a web application. I could also do the same thing using an application gateway. Could be also another option for this. All the previous options, if you go back here, like a public load balancer, doesn't make sense because we don't have a public IP address for this. So, and if we see traffic manager profile, it's not also basically the ID, because the idea here is to balance the load between those different instances, so we don't have that too. And Azure content delivery, well, that's for static files, so it's not this for sure. So the second question is about, I'm configuring a site-to-site VPN connection between Azure Virtual Network and my organizational office. What do I need to create first on the VNet? So basically, I'm establishing a VPN connection. What is the first thing that I need to do in my VNet? Create a network gateway, create the gateway subnet, an application gateway, or an express route connection. Well, if you see this one here, well, express route connection is like super overkill for this, and they precisely say site-to-site VPN connection, so it doesn't make any sense for sure. Then we have application gateways. Well, application gateways, like we saw before, is to serve as a load balancer for a web application. So again, that's not for sure the answer. So a gateway subnet and a network gateway, yeah, for sure I need both, okay, to have this and to create this. But the first one that I need to do is to create the gateway subnet, because my gateway, my network gateway, will have a prereq, that is the gateway subnet. So of course we need first to do the gateway subnet. So question number 3, you have a virtual network that contains a subnet named subnet 1. Subnet 1 has 2 virtual machines named VM1 and VM2. I need to inspect all network traffic between VM1 and VM2 during the next 2 hours. I propose to use the data collector set. Will this work? Well, yes or no, that will be the answer as well. In this case, the answer it is no. Okay, no, that will not be the answer. The same exact question, but now I have a small difference, is that I propose to run the packet capture on the Azure Network Watcher. Will this work? And the answer here is yes. So, and this explains both question number 3 and number 4. So the Network Watcher variable package capture allows you to create package capture sessions to track the traffic to and from a virtual machine. So the packet capture helps you to diagnose network anomalies both reactively as proactively. So this is why, okay, this, yes, it is the correct answer for this, for our case. In order to continuing with your learning journey of the topics that we learn here today, you have several self-paced learning resources on Microsoft Learn. You see here in the screenshot some learning paths that we have over there on administering infrastructure resources, managing resources in Azure, and each learning path is consists on several different modules. And you see some of them have 6, 9, others 12. So it's really big, the amount of content that you can have here. And even some of those modules that you see there, they don't only include like tasks for you to learn things, but also labs. So they have like a lab guide instructions for you to simulate. But in the real Azure subscription that the Microsoft Learns also provides to you, it's called an Azure Sandbox subscription, so that you can practice this in the real Microsoft Azure. So it's not any kind of simulated environment or something, but it is really the real thing where you can test out stuff and do some labs, which is pretty good what you can do with the Microsoft Learn modules. So tomorrow we're going to talk about monitoring resources by using Azure Monitor, and we're also going to talk about backup and recovery. So it's a full day just about those 2 services. So I hope I see you again tomorrow.
Thank you for sharing your knowledge with us today. I hope our participants will really benefit from it. Also, as an additional resource, let me remind you that this series on administering Microsoft Azure will also be available for you to watch on demand at aka.ms/enableVTS. In fact, you can find more virtual training series available for your on-demand consumption there. So thank you all for being here with us today. We'll see you again tomorrow. Have a great day. Bye.